All right, guys, so I'm going to skip around in the probability a little bit. Most of you guys did not have a really hard time with like this simple probability, aka like 62 through 68. I will say that all probabilities add up to 1, so that's a quick way to be able to find that white. For number 61, if you're asking, like, are they disjoint or independent? Disjoint means mutually exclusive. We have no information about this, so we can't say neither disjoint nor independent at this time. So let's move on and let's actually look at 69 through 74 because that asks for like a tree diagram, and that was one area that we weren't just like beautiful at. Or I say we, not all of us. All right, so suppose that in Mr. Willett's AP Calculus class, 71% of the students are seniors and 26% are juniors, 4% are sophomores. 36% of the seniors and 15% of the juniors are also in AP Stats, but none of the sophomores are. Use that information to answer questions 55 through 60. Oop, that is a typo, 69 through 74. So let's get this tree diagram drawn. So we know that we have AP Calculus class. So I'm going to say like AP Calc. We have 3 different things going on. We have seniors, we have juniors, and we have sophomores. So this is Calc. So we have 0.71, 0.26, 0.04. And again, that adds up to 1, so we know we're good to go so far. 36% of the seniors and 50% of the juniors are also in AP Stats. So let's go of the seniors, 0.36 are going to be in Calc and Stats. And then we can also say, actually, I can erase this and just say that this is going to be Stats as well because we've already clarified Calc. So this is going to be 0.64. And I'm going to say Stats not. Of the juniors, you have 15%, so 0.15 are in Stats, 0.85 are in not Stats. And we don't really have to do another tree on those sophomores because all 100% would be in not Stats. What is the probability that a randomly selected student is a junior in AP Stats? All right, so remember that when we're doing this, we have to work all the way down the tree. So a junior in AP Stats is going to be this like 0.26 times 0.15. It didn't give us a selected subset, so we're doing over everyone or over 1. So you would just come over here and say 0.26 times 0.15, and I would get 0.039. Is a senior randomly selected as a senior who is not in AP Stats? I need to make sure that looks like a 6. So I'm going to say that 0.71 times 0.64. A randomly selected student is a sophomore who is in AP Stats. There are no sophomores in AP Stats. That's a 0. A randomly selected student from Mr. Willett's class is also in AP Stats. We have 2 AP Stats tree lines, so really you're just adding up the probabilities from 70 and 71 because we're saying that they are a senior in AP Stats or they are a junior. Remember, or means and. So 0.71 times 0.36 plus 0.26 times 0.15, and that would give you that output that's on the key. A student, and that student is also in AP Stats. What is the probability that they are a senior? Great. So we're looking for all of the kids in AP Stats, so that would be that number from 73, right? So 0.71 times 0.36 plus 0.26 times 0.15. And the probability that they are seniors, so remember this is all stats, that are also in Mr. Willett's class. And then the probability that they're a senior is that 0.71 times 0.36. And after you get that math done, it should result in that 0.8676. Let's scroll down past this weird break. Sequences is most likely to occur. Remember that heads and tails are all independent events. So all of these sequences can be written by 0.5 raised to the 1, 2, 3, 4, 5, 6. This can be represented by 0.5 to the 6, 0.5 to the 6, 0.5 to the 6. So the answer is E because all are equally likely. True or false? A fair die is rolled 600 times. We always avoid exactly. We're going to say false here. As the number of rolls approaches 600, the proportion of 5s will get closer to 1/6. This is the law of large numbers. This is true. A run of 8 odd numbers in a row is impossible since the proportion of events as odd has to stay close to 50. False. Remember, we're always looking at the law of large numbers, which means that like eventually they get close to this predicted value, but we can never say that like, oh, this is bound to happen. The number of 3s rolled should be approximately equal to the number of 6s by the end. Keyword is by the end. This is the law of large numbers. It should, doesn't mean it will. The first 12 rolls will include 2 of each number to keep proportions equal. No. We don't know what's going to happen. There are so many different outcomes. You do not have to do 77 and 78. We did not go over that. We are going over that next unit. All right, suppose you were given a standard 6-sided die and told that the die is loaded in such a way that the numbers 1, 3, 4, and 6 are equally likely to turn up, and the numbers 2 and 5 are 3 times as likely to turn up. Cool, so let's get this done. You know that, I'm just going to write out the sample space. I'm just going to call this 1, 2, 2, 2, 3, 4, 5, 5, 5, 6. So we have 1, 2, 3, 4. 10 outcomes. The probability of 1 is going to be 0.1 or 1/10. The probability of 2, this happens 3 times or 0.3, 0.1, 0.1, 0.3, 0.1. And again, they all add up to 1. Let A be event, the number rolled is a prime number. Note that 1 is not prime. Find the probability of A. Remember, a prime number is a multiple of itself and 1 only. So that's going to be the probability that we have a 2 or 3 or 5. So when I get that, we're just adding because or means add. So I'm just going to say that this is going to be 0.1 plus 0.1 plus 0.3. And that is going to give me that total probability of an odd number. Let B be the event the number rolled is even. Find the probability of B. So we have 2, 4, or 6. So that's 0.3 plus 0.1 plus 0.1. So again, we are looking 1, 2, 3, 4, 5. Are A and B disjoint? That means like, do they have an overlap or like, are they mutually exclusive? And the answer to this is no, because 2 is in both. And if I wrote out that probability of B, even numbers would be a 2 or a 4 or a 6. This last question here of independence, I just like pasted in from those like notes we took the other day in class just to kind of like be a little reminder. Remember, if events are independent, that like math behind it would follow that the probability of A and B would be the probability of A times the probability of B. So if I think about like, let's just get the math done behind this, the probability that it is prime and even would be, so like, right, probability prime and even would be that this guy right here, he is the only prime even, 2 is the only prime and even number. So prime and even would be A and B, and that's going to be 0.3. And the probability of A times the probability of B does not equal 0.3. So these things are not going to be independent because they do not match that clause. You do not have to do 80, and then 81 and 82 are good to go on the answer key. So hopefully I will see you guys for office hours on Thursday if you have any questions, and good luck in your studies.